Today's video starts on page 22 in your packets. It's a problem of the day. Jimmy was trying to estimate the area of the lake where he goes fishing. The diagram below shows an aerial view of that lake. Use the diagram above to estimate the area of the lake. Well, that pretty much follows the pattern of a rectangle. I would probably draw a rectangle around that and find that area. Go ahead and do that. Explain what you did, how you got the answer. Do this entire page. And I want you to go back one page. So back one page to page 21 and do this page as well. I'm going to start it, however, for you. So this is also a problem of the day page. A cyclist took part in a competition. The distance traveled d meters after t minutes is given by distance equals rate times time, 700t. Give the relationship between t and d. Graph the relationship between t and d. Use 2 units on the horizontal axis to represent 1 minute and 1 unit on the vertical axis to represent 350 meters. So 1 unit to represent 350 and 2 units to represent 1. So 2 units to represent 1, 2, 3, 0, 1, 2, 3, 4. Yep, we're good. So this is time, and it's minutes. So we want to label our axes, right? And my other axis is distance traveled. And how am I traveling that distance? In meters. And it says 1 unit to represent 350. Will that fit on here? How far do we have to go? Let's see. We have to go up to 2,800. That is not going to fit on this little piece of graph paper. So, I'm not going to be able to follow that direction. I'm going to use 1 unit on the y-axis and call it 700. 700, 1,400, 2,100, 2,800, 3,500. Because I know I need to get to at least 2,800. And it wouldn't work if I count by 350s. So 1 in time 1, 0, 0, so that's one of the points. 1, 700. 2, 1,400. 3 is 2,100. 4 is 2,800. And I could keep going, right? I could do 5 because it will fit on here. 5 would be how much? 3,500. I could put that on there. It's not on the graph. It's okay. So I would like you to answer A, B, C, D, E, F, and G. To the best of your ability as part of the problem of the day pages. And I'm going to go on to the rest of the video on page 23. So on to page 23, the area of triangles and trapezoids. Now remember, Euclid loved the parallelogram. So here's a parallelogram drawn in here. And the formula for the parallelogram was area equals base times height. The diagonal of a rectangle and a parallelogram cuts it into 2 congruent triangles. So the formula for a triangle is half that of a parallelogram, 1/2 base times height. And you can see that the base and the height are labeled in these pictures. It doesn't really matter which side you call the base and which side you call the height. Any side of the triangle can be called its base. The perpendicular distance from the base to the opposite vertex of the triangle is called the height. So that 90 degrees, that's what perpendicular, it intersects at a 90-degree angle from the base to the opposite vertex. So, for instance, this base to its opposite vertex. And it's nice and easy to find the heights in right triangles, but in the parallelogram that I drew here, so here's my triangle, the shaded part, from the base to its opposite vertex, that perpendicular, that 90-degree distance, that's your height. Sometimes the height is drawn like this outside of the triangle. And they'll call the height out here. Sometimes the height's put outside, especially if it's an obtuse triangle. So the area of a, and this area of a triangle, this only works with doing length and width. It only works for right triangles, by the way. But, so generally it's area equals 1/2 base times height. That only works for right triangles, length times width. So here's our nice triangle, base and a height. Now again, remember, any side of a triangle can be called the base. The height of the triangle is that perpendicular distance from the opposite, from that base to the opposite vertex. So for instance, in triangle ABC, AX is perpendicular to BC. But I could draw another, what if I called, instead of BC being the base, what if I called AB the base? Then it's 90-degree distance, 90-degree that height from C, the opposite vertex, would look something like, you know, say that's 90 degrees. Well, that's not quite 90 degrees. I think it's got to come down a little bit. But 90 degrees from here, from if AB is the base to its opposite vertex, then this could be called the base, and this could be called the height. Well, what if AC was the base? Then I'd have to go 90 degrees. I'm slanting the way I'm looking at this, and my shadow's in my way, but this could be, AC could be the base, and then this dotted line over to B could be the height. So again, any side can be called the base. The height is the perpendicular distance from that base to the opposite vertex. So I'm going to erase that for now because I just wanted to show you it can be any base. So the area of triangle ABC is 1/2 base times height here. So I'm going to fill in what I know. I know 1/2. The base is 10. That height is 14. So half of 10 times 14, well, half of 10 is 5. 5 times 14 is 70. Or I could do 10 times 14, which is 140, and then take 1/2 and get 70. Or I could do half of 14, which is 7, times 10 and get 70. Doesn't matter when you take the 1/2, right? Because multiplication is commutative. So 1/2 times 10 times 14 is 70 centimeters squared. So remember, all geometry, formula, here it is. Area equals 1/2 base times height. Plug in the values. That comes next. Formula, plug in, answer with a label. In triangle PQR, PX is perpendicular to QR. PR is not the height of the triangle because it's not the perpendicular. This is not a right angle here, right? No, no, no. So to get, if QR is my base, to get a perpendicular distance to the other side, that vertex, oh, that's not going to hit it. We have to draw or extend QR and P down to that base, perpendicular to the base of QR, would have to come outside of it. So the height is actually P to X, which is called, which is 25 feet. So the base is QR, which equals 30 feet, and the height is PX, well, not Q, PX, which is 25 feet. QR, PX. So, writing the formula, if we're going to find the area equals 1/2 base times height. Formula, plug in 1/2. What do I know? The base is 30. The height is 25. So 30 times 25 is 750. Half of that is 375. And the label would be feet squared. Formula, plug in, answer, label. Next page. Complete to find the base, height, and area of each triangle. Each square measures 1 by 1. Okay, well, we have to know that. It's not, each unit isn't worth 2 or 5 or something else. So my base here equals 5. This is my base. I'm going to call that my base. I could call this my base, and then this could be the height. It really doesn't matter. But I'm going to call the one that I see there on the bottom, my base is 5. My height is 8 units here. This is my height. So my area equals 1/2 base times height. So 1/2 of 5 times 8, but 8 times 5. Again, I could change the base and the height. 8 times 5, taking half of it is the same thing as 1/2 of 5 times 8. That's 40. Half of that would be 20. Did they say feet? No, it just says units. So units squared. Okay, here's another obtuse triangle. That's the vertex, and here's the perpendicular. So the hint is, look for the box. Look for that perpendicular. That perpendicular is what is called the base and the height. That relates the base to the height. So since that's the vertex, this is the height, and this side has to be the base. Don't include these little dot, 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 dot things. That's not part of the original triangle. So my base here is 3. My height there is 4. So my base is 3. My height is 4. My triangle, 1/2 of 3 times 4, which would give me 6 units squared. 6 units squared. So look for those boxes, those perpendicular little boxes. Complete to find the height. Ooh, a little problem solving. JKL is 35 square meters. That's the area. Oh, they gave me the area. Find the height of the triangle. So we got to find this. So this must be the base. The base is 7 LK or KL, 7 meters. So area equals 1/2 base times height. What do I know? I'm going to plug in what I know. It's 35 is the area. Half of my base of 7 times a height that I don't know. I don't know what it is. Well, half of 7 is 3 5/10. I don't know the height yet, but I can solve this equation, right? Divide by 3 1/2. Well, 35 divided by 3 1/2 is 350, right? Whoops, 350 divided by 35, which is 10. 10 equals that height. 10 meters equals that height. 10 meters. So we can problem solve if we're not given both base and height. Next page talks about trapezoids. So figure ABDE, so the outside of this. ABDE, that's a trapezoid with bases of AE and BD and height EC. AE is parallel to BD. That's in a trapezoid, you have to have one pair of parallel sides. It's a quadrilateral, four-sided figure with one pair of parallel sides. The diagonal BE, you can see here drawn in, divides that trapezoid into 2 triangles. Both triangles have the same height. So this height is the same as ABE's triangle. The height had to be drawn outside because this is an obtuse angle. The area of the trapezoid equals the area of the blue triangle. Let's get some colors here. The blue triangle. Where's my blue pen? Here's my blue pen. This is the blue triangle, by the way. And the area of the orange triangle. So the orange one. Here's the orange triangle. Okay, so now they're blue and orange. So the area of triangle ABE is 1/2 base times height, and the triangle BED, 1/2 base times height. The heights are exactly the same. So if I add AE and BD together, right, because I'm adding those 2 triangles together, the sum of the lengths of the parallel sides, the bases, that's the bases. So the area of a trapezoid is half the height, right? There's the 1/2 BH part. And the bases is actually the sum of those 2 parts, the sum of the lengths of the parallel sides, base 1 plus base 2. So the formula for the trapezoid is half the height times the sum of the bases. Half the heights times the sum of the bases. And B1, it's read B sub 1 and B sub 2. I just say base 1 and base 2. So the area of a trapezoid, 1/2 the height times the sum of the bases. And remember, the bases are always the parallel sides. Always the parallel sides. There's only one pair of parallel sides, so you got to find those. And then the height, remember, that's going to be the dot, 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 dot box, the 90-degree angle. So look for the box. That's the height. So let's look at this trapezoid. In figure TUVW trapezoid, it's a trapezoid. TW is parallel to UV. Well, we could have probably figured that out without them telling us that these sides are parallel. So this 14 is the height, right? So there are the bases. So if I'm finding the area of this, area equals half the height times the sum of the bases. And my height is 14. My bases are 12 and 26. Really doesn't matter which one you call B1 and B2. Usually the littler one's B1, but you could, 26 plus 12 is the same thing as 12 plus 26. So half of 14, I know that's 7. Or I could do half of the sum of the bases, which is 38, which is 19. 19 times 14, not so much. Not as easy as doing half of 14, which is 7. 7 times 38, that is 266 centimeters squared. Each square measures 1 unit by 1 unit. So to complete, find the sum of the bases, the height, and the area of the trapezoid. Okay, so number 7, same thing. I know the height of this guy, box. There's the perpendicular, right? This is the bases. That's base 1. Here's base 2. Base 1 is 3. Base 2 is 7. The height is 3. So do I have everything I need? Yep. Area equals half the height times the sum of the bases. Formula. Plug in half of 3. That's not so nice to do. Half of 3. And the bases are 3 and 7. Oh, I can take half of 10 much easier. Half of 10 is 5. 5 times 3 is 15. And it's just units squared. Oh, where's the parallel sides? Well, that's one of them. That's one of the bases, which is 1. And the other base, this would be base 2, that's 3. So the perpendicular distance between these parallel sides is right there. It's actually the side of the trapezoid, and that's the height, which has 4 units. So I have all my information. Half the height times the sum of the bases. Half of 4, well, that's nice. That's just 2. And adding my bases together, that's 1 plus 3. Well, that's also 4. Half of 4 is 2 times 4 is 8 units squared. And the last problem here. The area of trapezoid ABCD is, so they've given me capital letter A. Here's my height, because I see the box there. So DC is my height. Do I know that? I don't. Oh, we got to find the height. I have the 2 bases. Here's B1, and here's B2. This little V here means that that's the parallel sides. And I can probably tell that looking at it as well. So area equals 1/2 the height times the sum of the bases. This time I don't have the height, but I do have the area. So 1,248 equals half of, I don't know, plus 22 plus 38. What is that, 60? So half of 60 is 30. 30 times some number has to equal that 1,248. And I would divide by 30 on both sides. That's not going to be a nice answer. That's not going to go in equally. 41 and 6/10. 41 and 6/10. And that's my height of 41 and 6/10 centimeters. It's not the area, so don't say centimeters squared. It's just one dimensional. It has one length only. So it's only centimeters. And that's it for today's video.